I'm Noah Campbell, Technical Marketing at BlackBerry, and we're here with Shiladitya Sircar, Senior Vice President of Enterprise Software, to discuss malicious destination and phishing detection with CylanceGATEWAY. But first, Shil, please introduce yourself.
I'm Shil, as you mentioned, and I lead R&D cybersecurity solutions here in BlackBerry, and my focus is on network and content protection, threat detection that are originating from the network. So it's basically the solution that we go to market with as the ZTNA content solution.
Fantastic. So, as we think about that and all the things that are intertwined with the ZTA solution and what we want to see in that kind of solution, we think about, malicious destination detection. What are malicious destinations exactly?
Yeah, so a malicious network destination, I think to be precise, is any destination on the network that is serving a malware or attempts to collect private and sensitive information from the end user without them kind of realizing.
And we're also talking today about phishing. So what are some different types of phishing we see as well?
Yeah, I think, before answering that question, I think I just want to take a few moments and kind of explain this landscape. In any attack campaign, the adversary goes through various stages in executing a successful attack. And I think the goal is different types of attacks have different purposes, right? Different adversaries, different threat actors that are operating, and they all have different purposes. But in the context of phishing, really, the purpose is to deceive and trick the user in obtaining sensitive content, whether it's your credit card information or your password or your credentials, or to get enough information from the end user to mount a subsequent attack. Most of the damage is sort of done in this very initial stage where you're collecting sensitive information that you're going to leverage. And not all attack campaigns are done by the same threat group for all of the different stages. It's almost like a service, right? So, somebody could have all of these harvested information and then sell it, and then it's used for another kind of attack. But in any case, the different stages and the goals of these threat actors are really to establish a mechanism on collecting private and sensitive information, deception, social engineering, so that these can be actually used to perform the necessary breach or the necessary goal that this campaign has in mind. So now I come to phishing. So phishing is really a way that exploits the end user's muscle memory, right? You see content somewhat familiar and you start clicking, right? Or you see a password pop up, which is a password fatigue, and you see your username fills in and you enter your credentials. So phishing is really a way for deceiving the user with some familiar content that hands over the threat actor where the end user voluntarily, in this case, perhaps not knowing, but disclosing the information that is required, whether it's credit card, passwords, or filling out a form, it could be anything, social insurance numbers, etc. At work, or, we are also fatigued with password prompts all the time, and, we look at a known and familiar login page somewhere, and we think, yeah, this is, and, we type in our credentials, and things like that. So it's really playing with that, muscle memory or behavior that we're used to doing.
Right. Right, that we're all trained to now do that we think is good behavior. And even on things like the multi-factor authentication, we're seeing folks do, prompt bombing, right? So you're just so used to saying accept that you're just, have it. If it shows up on the device, I'm probably going to just click accept. Yeah.
Exactly.
Now, would you say kind of malicious destinations and phishing kind of go hand in hand? We use phishing to lead you to a malicious destination?
Yeah, I think the correlation is that, it's kind of two kinds, right? So the purpose of phishing is to harvest information, right? To account for, if you're a high value user in the sense for an enterprise, right? And you have access to multiple different things. So harvesting your credentials is very important, right? For example, in mounting a meaningful attack, for instance, for the threat actors. Whereas leading leading you to malicious destination is almost an ability for the threat actor to deceive you to navigate to something where they can deploy a malware. So I would say they're separate in the intent, but the purpose is the same, which is deception.
So, we've outlined kind of what the issues are here. So now that, to avoid the focus on doom and gloom, what can we do about it, right? So specifically, a lot of the work that we're doing here with Silence Gateway and the work that you and your teams are doing to build Silence Gateway, let's hear a little bit more about it.
It is an extremely difficult problem. And the reason for this is that it is basically, you almost need a technology that is continuously observing the end user's behavior and the destination that they're trying to go, and then continuously evaluating whether this destination is masquerading as something else that it is not, or basically to detect the deception on behalf of the user. Okay, because the destination in itself is what the user is interacting with, and providing necessary protection by either blocking it, stopping it, notifying the user are the different means to kind of stop it before the user is given the opportunity to interact with it. Right? So Silence Gateway is a ZTNA product, and the aspect of VPN is, in a conventional VPN product, you take the user's credential, you know who this person is, and then you let them connect to your corporate network and then expose all of the assets that are in the network, even though the user is coming from the outside. So you implicitly trust that endpoint to attach just because the user has claimed their identity in whatever system that the enterprise may have. And so Silence Gateway is different in many ways. So firstly, we have a very sophisticated way of detecting, and over the years with Silence, we've built machine learning models that help us understand the maliciousness, if you will, of the destination, and then continuously evaluate that and monitor access attempts of those destinations using these machine learning models that evaluates and scores these destinations and tries to ascertain the probability of authenticity and the reputation looking at various indicators. And these machine learning models, they have learned the anatomy of what a legitimate destination looks like and behaves like, and ones that do not, right? So using these information and correlating signals from different sources using our suite of products, we're able to sort of decide and protect the user by either stopping it or preventing progression of that stage where the user is able to interact with the content such that they're not exposed and having to make that decisions themselves. That's the goal. And legacy VPN product is a networking product. The intent of those products are so that how to connect from point A to point B. So that's it's almost a different solution, different technology to solve different types of problems. Yeah.
That's an interesting point too, that it's, you've got, sometimes it's apples and oranges here with some of this stuff, right? Because the VPN is meant to give you that network connectivity, like you said, and kind of give you access to everything, which presents risks because we're exposing more on the internet than we maybe have to or need to with that, individual who's trying to connect, coming to the, from the outside, coming to the network. But from a ZTNA perspective, we are, kind of these network overlords watching at all times to make sure that we are, observing the taxonomy of a typically malicious, network destination. And as you interface with that, we're going to be able to, prevent you from running into that destination is the goal.
Yeah, absolutely. And your traditional VPN brings all your traffic to on-prem, right? That's what it does, right? It attaches to wherever the head end is. And then that traffic typically would traverse through a firewall hardware that is deployed on premise, and then that firewall makes a decision whether it has to go to the internet or whether it has to go to the some assets that it is behind that firewall. So you're taking all this traffic, internet-bound traffic, for example, and you're bringing it on-prem, and then typically these firewalls also are they have these block lists that try to sort of block malicious destinations and things like that. And typically your traditional VPNs typically would do this, and then it'll go through the firewall, and the firewall would stop, for example, right? By looking at the domains or the IPs or whatever these access attempts are. So the challenge that is faced with this type of a sort of moat and sort of castle type of model is that it first needs to bring all of these untrusted, unverified traffic on-prem for inspection, right? Which exposes the threat landscape. And secondly, these block lists, which are typically static in the sense that they get updated every now and then, but are sort of fixed in time determination of where the attack is originating from. And these attacks, typically phishing especially, are very short-lived, right? And they move very fast and are very dynamic. So if a destination attempt is not there in the block list, for instance, the destination will be allowed. And if these things are changing so fast, I mean, these threat actors are also on the cloud, right? I mean, they're using all these modern tooling, right, deploying software and keeping things up to date very fast. So that's why there's a need for this continuous evaluation by observing the traffic, evaluating the destination, scoring the traffic, scoring the destination on every access attempt, and also stopping it at few stages ahead before even allowing the traffic to traverse through the on-premise or the private network.
Right. And it's an interesting point too with the block list, right? Like we're having so many new scams and malicious network destinations and all these kinds of things pop up time over time over time. There's just no way to keep a static list up to date at all times, right? Nobody has the capacity to actually do that. Because these threat actors are moving quicker than the VPN can catch up with them in many cases. So we've got these malicious destinations and how we're protecting from that with backing with some of our AI and machine learning technology. So let's talk about phishing as well, though. How can we also use Gateway to tune and protect against phishing? We're from the malicious network destination perspective, we're going a step above of the kind of standard block list and being cognizant of how we can use AI and ML to prevent against that. But phishing, how can we actually kind of prevent that? What does that look like for us from a gateway perspective?
Yeah, so I think, again, it's leveraging machine learning. So I think phishing, one of the things that we talked about what phishing is deception, right? It's visual deception and deception on your familiarity, right? So for example, in Gateway, our machine learning models, they try to identify a few things by looking at various indicators that are network-centric, that are statistical, and these are all inputs to the machine learning models, which are visual indicators of how the content is structured, indicators of various things. Without getting into specific, I think it's looking at sort of all of the possible discernible attributes that identify a specific destination, its content, its relationship, if you will, and then making an assertion and scoring them as a probability over time as a function and deciding whether this is a phishing attempt or not.
And what I want to really emphasize, like I use Gateway every day for my daily kind of connectivity needs. When we tend to explain these things, it sounds like a complex process, but from the end user's perspective, if you were to run into a malicious destination or if you were to run into a phishing issue, from my experience with using Gateway, the connection's blocked and then you go on about your day. Right. So if we think about what we were talking about at the beginning of the conversation, people are so busy, they don't have time, not only from a perspective to watch out for some of this stuff themselves because it's continuing to get more sophisticated, but when they do run into an issue, it shouldn't stop their whole day.
I think that's a great point. I think from an end user's perspective, it's actually, they don't even see it. It's almost there watching and taking actions, and if it does something, it just notifies the user. And that's about it. It's not, at the end of the day, CylanceGATEWAY is a productivity tool, right? It enables hybrid workforce. It enables, being able to create ZTNA segmented networks. It enables administrators to kind of protect their assets, assigning a very strong identity-centric user destination application boundaries so that, you can create very sophisticated access control capabilities so that you don't have to expose assets to endpoints and always verify, right? So it's a productivity tool. So from an end user's perspective, they of course don't see it, but it is continuously monitoring, watching, and protecting the user having to make these decisions themselves. So I think from a usability perspective, yeah, the end user, it's almost not there.